Very good morning, students. I hope my voice is audible to all of you. Please respond.
Good morning. You are audible.
Kush, am I audible?
Yes, sir, you are audible.
Hello, Kush, am I audible now clearly?
Yes, sir, yes.
Okay, thank you. So, very good morning to all of you. We are having in 1A11 batch regarding the ACD lab, Analog Circuit Design lab. So, I'm going to start the lab. For the very first lab, we are going for basic introduction of the experiments as well as what we are going to do in the labs. Very soon, a screen would be shared to all of you. The screen comprises of list of experiments for this particular subject. I hope my screen is visible to all of you. Please respond.
Yes, sir.
Okay. So, as you are aware that we are dealing with analog circuit design lab of 1A11. In this lab, we will be basically focusing on two important components. One is operational amplifier, that is IC741 or commonly known as op-amp. And the second main component of the whole laboratory would be any 555 timer. Following is the list of experiments to be performed by you all guys. Just for your information, this particular operational amplifier data sheet, list of experiments have been uploaded in your MS Teams. I hope all of you might have received the same. Please respond yes or no.
Yes,
Hello
sir.
students. Okay, thank you. So now we are going to I will just get you familiar with the terminologies about operational amplifiers. Students, operational amplifier is a 8-pin IC. There are 8 different pins and each pin has its own importance. We are going to perform the operations on this IC to see the results of various amplification factors, which includes inverting, non-inverting amplifiers, maximum gain, CMRR, slew rate, offset voltages, etc. Along with that, we will be moving towards multivibrators and filters, whether it is low pass or high pass, based on operational amplifiers and any 555 timers. This is the basic list of the experiments. Along with this, to start with the very basics, I am hereby sharing with you the screen, which is LM741. LM741 is nothing but the operational amplifier IC datasheet. See, why I am saying about it is I hope the screen is visible to all of you.
Yes, sir.
Yes, sir.
The screen comprises of IC741. As I have told you, IC741, that is operational amplifier, it is a 8-pin IC. You can see the 8 different pins and the configurations or the importance of each and every pin of IC741. I will start with pin number 1. Pin number 1 is basically offset null. It is the same as that of pin number 5. But the thing is that pin number 1 is plus offset null and pin number 5 is minus offset null. So what is the difference between plus offset null and minus offset null? Or rather, I will start with the first term, that is, what do you mean by offset? Offset in case of operational amplifier is termed as if we do not supply, I repeat, if we do not supply anything as input to my transistor or to any particular semiconductor device, then what should be my output? Yes, Nadir? Hello, Nadir?
Yes, sir.
If I am not providing anything to my input of a semiconductor device, let it be a PN junction diode or a transistor or whatever it is, then according to you, what should be the output?
Nothing.
Nothing. So the thing is that it is an ideal case that if we are not providing anything at the input, either AC or DC voltage, there should not be anything at the output side. But practically speaking, what happens is due to the presence of passive elements like capacitors, resistors, etc., we receive certain kind of reactances or impedances. Those reactances and impedances react and propose or provide certain kind of millivoltage or milliamperes at the output terminals. Milliamperes or millivoltage at the output terminals. To avoid this kind of milliampere or millivoltage, that is, to avoid these voltage or current values, we need to have we need to have enough amount of resistance inside the circuit which would not allow that flow which would not allow that flow. If I say enough amount of resistance, that can only be on the basis of a rheostat or a variable resistor. So in case of operational amplifiers, what we do is we connect a rheostat or internally a rheostat or a variable resistor is being connected between pin number 1 and pin number 5 to nullify the output, and hence it is known as offset nullification, to nullify the offset voltage that is being received at the output without providing the input. Is it clear? Should I repeat? Students,
No, sir.
please respond, beta. I know you are familiar with the online classes, so you think that you do not react and it would go on. Please do not do that thing because it will lead to a frustration from both the sides. So I request all of you to unmute yourself so that we can interact in the lab sessions. I request all of you to please unmute yourself. Sahil, hello Sahil. Sahil, am I audible?
Yes, sir.
Hello Sahil, how are you?
Fine, sir.
Okay. Sahil, are you able to understand this offset nullification? Hello Sahil, are you able to understand this offset nullification? Sahil, please respond. Assignment number 10 Smith.
Yes, sir.
હા બેટા ખ્યાલ આવે છે?
Yes, sir.
Okay. So now pin number 2. Pin number 2 is nothing but known as inverting input pin. This kind of pin provides whatever is being provided to the input, it gets inverted. it gets inverted. Inverted in the sense, suppose I am going to provide plus 2 volt, then by the use of this particular pin, we will receive minus 2 volt inside the op amp. If I say plus 2 volt is being provided, then at the output side we would receive minus 2 volt. Minus 2 volt would be output side, means minus 2 volt would be provided inside the chip. So that particular pin, pin number 2, inverts our provided input. Pin number 3 is a non-inverting input pin. Pin number 3 is a non-inverting input pin. Pin number 4 and pin number 7, the most useful pin in the whole operational amplifier. Pin number 4 and pin number 7 is the most useful pin in the operational amplifier. Pin number 4 and pin number 7 are being provided with a constant voltage supply. As you can see, it is written over here V minus and V plus. So, pin number 4 and pin number 7 is a constant voltage being provided in the circuit, whichever or whenever we draw a op-amp based circuit, either in the copies or in the practical exam or in the exams or in the test, whatever it is, whenever we draw the circuit of operational amplifiers, remember one thing. I repeat, remember one thing. While drawing the circuit in case of operational amplifiers, pin number 4 and pin number 7 has to be provided compulsorily with a constant voltage. Pin number 4 and pin number 7 has to be provided with a constant voltage. Practically speaking, for LM741, the value of pin number 4 and pin number 7 is plus minus 15 volt. Practically speaking, the value of pin number 4 and pin number 7 is plus minus 15 volts. But as the IC changes from brand to brand, as the IC changes from brand to brand, in that particular case, it may vary to plus minus 12 volt. It may vary to plus minus 12 volt. As a result of which, pin number 4 and pin number 7 plays a quite important role in understanding the terminologies that a constant voltage is to be provided to the circuit. After pin number 4 and pin number 7, then comes pin number 6. As it is written and mentioned too, pin number 6 is nothing but the output voltage. Pin number 6 is nothing but the output voltage. The symbolic representation of operational amplifier, the symbolic representation or the symbol by which we draw the circuit of operational amplifier is a triangle which reflects input pin number 2, input pin number 3, output pin number 6. Pin number 4 and pin number 7 is the constant voltage supply. Pin number 4 and pin number 7 has a constant voltage supply. As you can see in the circuit of LM741, a triangle is being drawn. Now we are having pin number 2 and pin number 3 as our input pins. Basically, there are various connections. In case of operational amplifiers. Either it is single-ended, double-ended, multi-ended, etc. If I say single-ended, that means one of the inputs is being provided with the voltage supply and the other input is being grounded. I repeat, one of the inputs is being provided with the voltage supply and the other input is being grounded. As you can see in the circuit, pin number 2 is being grounded and pin number 3 is being provided with the voltage supply. Similarly, there is a feedback resistance. There is a feedback resistance, that is a wire connecting pin number 2 and pin number 6. So this is a closed loop. If pin number 2 and pin number 6 are not connected, then it becomes an open loop circuit. As you can see over here, it is an open loop circuit otherwise. Pin number 6 is at the output. Pin number 4 and pin number 7 is being constantly provided with a supply of plus minus 14 volts or 15 volts accordingly. For performance purpose, what we are going to do is we are going to implement the circuit in multisim. I repeat, we are going to implement the circuit in multisim. You have already used multisim live editor. For performing the experiments. Along with the performance, what we are going to do after this is we will also evaluate the circuit in VLabs, that is virtual labs. We will also evaluate the circuits in virtual labs for further clarification and understanding. We will also perform the experiments in lab and share with you the videos. I think within a month or so we may have our online classes instead of offline. We may have our offline classes instead of online classes. So it would be a greater exposure to have lab videos along with virtual labs and these experiments done by yourself on the live editor, that is simulator of National Instruments Multisim. In the past also you have performed the experiments in Multisim live editor, so it would not be a difficulty for all of you to perform the similar experiments over here in Multisim. I hope I am able to clear your thoughts and ideas about the experiment.
Yes, sir.
Yes, sir.
In the similar fashion as we have done in the past in network theory subject, we would be performing the experiments online along with virtual labs and writing the lab files. Once the lab file is being written, it would be shared to me through the drive. I will give you the drive access as we have done in the past also, so that you can upload your material on those same folders. Would it be comfortable or would you like to mail me and I will check it like that? The way you want. Please let me know. Chanvi,
Yes, sir.
બેટા શું કરવું છે? ડ્રાઈવ એક્સેસ આપી દઉં કે મેલ કરશો?
Sir, drive will be comfortable.
ડ્રાઈવ વિલ બી કમ્ફર્ટેબલ? ઓકે,
Yes.
તો હું તમને ડ્રાઈવ એક્સેસ આપી દઉં છું ઇન્ડિવિજ્યુઅલ ને, એટલે તમે એના અંદર જ તમારો એનરોલમેન્ટ નંબર જોઈને તમે એક્સપેરિમેન્ટ્સ મુકતા રહેજો. બરાબર છે?
Yes, sir.
All of you, please respond. Janvi has given this suggestion, which was given is approved. Okay. So enrollment number 9, enrollment number 10.
Yes, sir.
Yes, sir.
I hope in this semester you would be regular in submissions.
Yes, sir.
Sure?
Yes, sir. Yes, sir.
Enrollment number 10.
Yes, sir.
Okay. Thank you. So guys, this was the briefing about this particular subject, laboratory experiment. We would be performing inverting amplifiers, non-inverting amplifiers, basic circuits of op-amp. So I request all of you to kindly go through the virtual labs of IIT Kharagpur for analog circuit design or for operational amplifiers, and you would be able to understand how the experiments are going to get performed. And for that particular purpose, your first basic aim should be you must read the file that I am sharing, that is LM741. It is being shared in your team's general profile of 3141002 subject. I hope you can see the file which is being uploaded by me So please refer that file so that it becomes easier for you to download and read the file. It is basically a data sheet which helps you to perform the experiments and to understand the basics. Hello students.
Yes, sir.
Hello.
Sir. Yes, sir.
Okay, just wait a minute. Just wait a minute, students. I hope the screen is visible to you. The list of experiments for ACD subject along with LM741 file is being shared to you on Tuesday itself. So you can refer that particular data sheet and try to understand how the experiments are going to get performed. Is it clear?
Yes, sir.
Yes, sir.
Yes, sir.
Okay. So guys, this is our first introductory lab. So do not worry. I would not be boring you much. You can understand the things. You can download the data sheet, start reading it, and then performance would be in the next particular, you know, lab experiments. That is, on next particular Friday, you would be having lab. But if I'm not wrong, then next Friday is 25th December, so it may be a Christmas holiday. So do not worry. We'll perform the experiment along with next to next, maybe. In due course of time, I would inform you if there is a leave or not on that particular day. Okay, guys?
Okay, sir.
Yes.
Okay, sir.
Okay. So just wait a minute. I can take your attendance, then you are free. And all the numbers which are present are 2, 5, 6,
Present,
7,
sir.
9, 10, 11, 12, and 13. So the following students are present, rest are considered to be absent. Thank you guys. That's all for today's introductory lab, where we had discussed about the data sheet of 741. Along with the data sheet, we have understood that how we are going to perform the experiments. If those persons who are new to the lab, they may please note down what are the things that has to be written in your experiment number 0. I repeat, experiment number 0. Experiment number 0 would be the data sheet reading of LM741. Experiment number 0 would be the datasheet reading of LM741, where you need to attach a single page briefing the pin configuration and the constant values of LM741, that is the practical values along with the ideal values, a comparative table of practical and ideal values of LM741. in your experiment number 0. But in rest of the experiments, what you need to do is you need to write aim, apparatus, theory. I repeat, aim, apparatus, theory, circuit diagram, procedure, calculations, observation tables, graph if any, and conclusion. In case anything else is required for a particular experiment, I would let you know very soon. That's all from my side, guys. Thank you. In case of any doubts or any queries, please feel free to ask. Okay, students, thank you.
Thank you, sir.
Thank you, sir.
Thank you, sir.